right, so today we're going to talk about learning target 2, which says I can find the intercepts of a function in various forms. Learning target 1 talked about the slopes. Now learning target 2 is talking about the intercepts. Now the key piece of information that you need to know about how to find the intercepts are the x-intercept happens when y is 0, and the y-intercept happens when x is 0. Now the intercepts are the 2 points where a function crosses the axis. So let's say you have this line right here. The x-intercept would be right there, and the y-intercept would be right there. It's where your line intercepts or crosses through or runs into or is caught by each of the axes. Now if we're looking at finding the intercepts in the 3 types of equations, in slope-intercept form, let's just make up an equation. Remember, slope-intercept form is y equals mx plus b. If we want to find the y-intercept, we put in 0 for x. So let's consider this equation right here. We'll do 3x plus 6. So here's just an example equation that I made up in slope-intercept form. If I want to find the y-intercept, that means I put 0 in for x. I'm going to zoom in a little bit there. So here's what that would look like. Y equals 3 times 0 instead of x plus 6. So when I simplify that, 3 times 0 is just 0. So that would cross out, and I would get y equals 6. This means that my y-intercept happens when y is 6. So if I write my answer, then I'm always going to write the intercept as an ordered pair. So I put 0 in for x, that's my x-coordinate, and then 6 is the y-coordinate. So the y-intercept happens at 0, 6. If I want to find the x-intercept, that means I put 0 in for the y value. So now I'm going to have, instead of y equals 3x plus 6, I'm going to have 0 equals 3x plus 6. And then I solve this for x. So I subtract 6 from both sides. So I get negative 6 equals 3x. Divide both sides by 3. So x equals negative 2. And that means that my x-intercept is x is negative 2. And that happens when I put 0 in for the y-coordinate. So here's my y-intercept when x was 0. And here's my x-intercept when y was 0. And I always write the intercepts as an ordered pair. This means that if I were to graph this function, it would cross the y-axis at 6, and it would cross the x-axis at negative 2. In point slope form, that looks like this: y minus some y-coordinate equals the slope times x minus some x-coordinate. For this one, we are going to, if we have, let's say, y minus 3 equals, we'll have a slope of 2, and x minus 5. This is our line that I just made up. Now, for the y-intercept, we put 0 in for x. I need to separate these. So for the y-intercept, I'm going to put 0 in for x. So I'm going to put a 0 right there, and then try to figure out what y is. Whoops, that should be a minus sign. So I'm going to have y minus 3 equals 2, and then 0 minus 5. So if I simplify this, I have y minus 3 equals, now 0 minus 5, that's negative 5, times 2 is negative 10. So if I add 3, y equals negative 7. So that means that my y-intercept is happening. I put 0 in for x and negative 7. Now the x-intercept happens if I put 0 in for y. So now I'm going to say 0 minus 3 equals 2 times x minus 5. So I have negative 3 equals, if I distribute, I have 2x minus 10. Now when I solve this for x, because I'm out of room, I'm just going to add 10 to both sides. So I get, if I come up here, 7 equals 2x, divide by 2, so x equals 3.5. So that means when I put in zero for y, my x-coordinate was 3.5. So that's the x-coordinate. Whatever intercept you're trying to find, you put 0 in for the other one. Now when I think of standard form, that looks like, I'm just going to make up numbers, some number times x plus some number times y equals some number. It's much easier to find the intercepts here, because when I want to find the y-intercept, that means I put 0 in for x. If I put a 0 in there, this whole term is going to cancel out. I'll have 2 times 0 plus 4y equals 12. Well, that goes away, so 4y equals 12. Divide by 4, y is 3. So that means that my y-intercept is 3. When I put 0 in for x, I got 3 as my y. Now if I find the x-intercept up here maybe, now I have 2x plus 4 times 0 equals 12. So that goes away. I have 2x equals 12. Divide by 2, x equals 6. So that means my x-intercept is, when I put 0 in for y, I get 6 for x. So my y-intercept, I put 0 in for x, and I got 3, so it's 0, 3. My x-intercept, I put 0 in for y, and I got 6, so it's 6, 0. So to find each intercept, you put 0 in for the other number, and then solve. Now if we consider a graph, graphs are much easier to tell. We can look to see where are the places where each of these are hitting the x-axis at. Now this actually looks like this. That looks like that. So to get from one line to the other, oh sorry, so where is hitting the x-axis at is the x-intercept is happening at about 3.5, the way that I drew my lines. I'm not sure if that's completely accurate, but it's crossing the x-axis between 3 and 4. I will say it's heading at 3.50. And the y-intercept is just the place where it's being the y-axis, which is happening at 0, 3. Over here, this is a little bit better. The place where it's hitting the x-axis is at 1, 2, 3, 4, 0. And the place where it hits the y-axis, the y-intercept is at 0, 3. Here, again, this one's a little bit hard to read, but it's hitting that's where they're at there. It's hitting the x-intercept, or the x-axis, so the x-intercept is at 4, 0. And the y-intercept is at 0, negative 3. Now this one, the x-intercept, is at 1, sitting right there on the x-axis. So it is 1, 0. And the y-intercept is 0, negative 2. Notice that in all of these cases, if we go back to our key point, the x-intercepts happen when the y-coordinate is 0. There, 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 and there. And the y-intercept is happening when the x-coordinate is 0. There, 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 and there. So if we keep the same thought in mind, let's look at these tables. Remember that the x-intercept happens when y is 0, and the y-intercept happens when x is 0. So if we look at this table, if the x-intercept happens when y is 0, and remember y is like f of x, this point right here is the x-intercept, 1, 0. And the y-intercept happens when x is 0, so that happens right here, 0, negative 2. At this table, the x-intercept happens when y is 0, so that's up here, negative 3, 0. The y-intercept happens when x is 0, so that's here, x is 0, at 0, 21. Over here, the x-intercept happens when y is 0, so that is at 3, 0. And the y-intercept happens when x is 0, but wait, there is no x. So what we need to do is continue the pattern. So if you go 5, 4, 3, 2, 1, 0, we just kind of keep that out of it there. So to keep our pattern going up, 8, 4, 0, negative 4. I'm subtracting 4 each time, so it would go negative 8, negative 12. So it's 0, negative 12. My y-intercept wasn't listed on this table, so I just had to continue the pattern until I got to the place where x was 0.